Hi, welcome back to our physics KSSM. So today we discuss about 2.6 force. So you can refer to your textbook on page 64. Most of our daily activities involve forces. A force can change the state of motion of an object. How does a force change the momentum of an object in motion along a straight line? Actually, if we discuss about force, every day there is an action of force that done by us. Okay, now in this topic we want to discuss about the relationship between, there are three variables that is very important, that is force, acceleration and mass. Okay, now you can refer to activity 2.13. The aim of this activity is to investigate the relationship between force and acceleration and the relationship between mass and acceleration. Apparatus needed: ticker timer, alternating current power supply, runaway, 3 trolleys and retort stand. The materials: ticker tape, cellophane tape, 3 elastic strings with a knotted loop at each end. Okay, we divided it to two parts. Okay, the first part A, we want to investigate the relationship between force and acceleration with a fixed mass, meaning the variable that kept constant throughout this experiment is mass of the trolley. Okay, look at the diagram. The diagram shows arrangement of the apparatus given. So we have the ticker timer. This is a retort stand to clamp the friction capacitor runaway. And then we have a trolley, a ticker tape, alternating current power supply, and elastic string. Okay, instruction. Number 1, set up the apparatus as shown in figure 2.51. Switch on the ticker timer and pull the trolley down the runway with 1 elastic string. So meaning 1 elastic string represents 1 unit of force. Calculate the acceleration of the trolley using the ticker tape obtained and record it in table 2.1210. Number 4, repeat steps 2 to 3 using 2 elastic strings and 3 elastic strings with each of the strings stretched to the same length as that of the first elastic string in step 2. Plot the graph of acceleration A against force F and state the relationship between acceleration A and force F. Alright, for this experiment, we have mentioned earlier there are 3 variables involved: force, acceleration and mass. One will become constant variable, that is mass of the trolley. Force will become manipulated variable. How you control the manipulated variable for this experiment, that is a force, by using different number of elastic string. And then the one that you calculate or you get through the experiment carried out from the ticker tape, you calculate acceleration, meaning responding variable is acceleration. So how we make sure, or how we fix the manipulated variable? The word mentioned here, pull the string to the same length. Meaning in the procedure, you need to mention stretch to the same length. If you use one string, for example, you stretch to 5 cm, the next step you repeat with 2 elastic strings, meaning the 2 elastic strings also must stretch to 5 cm. And also the same thing, if you use 3 elastic strings, you need to stretch to also 5 cm. That one we call it stretch to the same length. That one we call it control the MV. So meaning the MV can be repeated by using different number of elastic string. If you want 5 set of data, you can repeat until 5 elastic strings that stretch to the same length. Then we record the reading. We have the table here, table 2.10. Here they use only 3 elastic string, the maximum, so we have 3 sets of data. So from the ticker tape, you can calculate initial velocity. Let's say you refer to 10 ticks of strip of ticker tape, or you can make a tape chart. Okay, so you can just cut out about 10 ticks from the ticker tape. You calculate acceleration. For example, the first one elastic string, you calculate initial velocity u, final velocity v, time taken, and then use the formula A equals V minus U divided by T. So you calculate acceleration for each of number of elastic strings. And then from the result that we get from the table 2.10, we can plot a graph of A against F. And then from the graph, we can state the relationship between force and acceleration. Okay, the second part, we want to investigate the relationship between mass and acceleration at a constant force. Again, there are 3 variables. Now for the second part, we make it force as a constant variable. We control mass as manipulated variable, meaning we repeat the experiment by using different masses of the trolley. And then from the experiment, we calculate acceleration. So acceleration is responding variable. Instruction. So actually the step is still the same as the first part. But in this part, we make it constant the force, meaning we can use 2 elastic strings stretched together for the whole experiment. And then we repeat experiment by using 2 trolleys and 3 trolleys. If you want to add some more until 5 set of data, you can add 4 trolleys and 5 trolleys. And then we can record the data in the table. We can calculate the acceleration. The same thing we do. From the ticker tape, we cut out about 10 ticks, then calculate initial velocity, final velocity, time taken, and then acceleration. From the set of data that we get, we also can plot a graph. Now we plot a graph of A against reciprocal of mass, 1 divided by m. So meaning here we have 1 trolley means 1 divided by 1. 2 trolleys means 1 divided by 2. 3 trolleys means 1 divided by 3. Okay, then we record data. We plot a graph of A against reciprocal of mass. And then from the graph, we can state the relationship between acceleration and mass. Theoretically, what we can get through the activity. Actually, from the first part of the activity, relationship between acceleration and force, mass is constant.